Today we are going to be taking a look at vectors and scalars, but before that we have to talk about physical quantities. So a quantity is basically anything that can be measured. For example, let's say we have two people here. Let's name them, I guess, Ahanaf, and let's call this guy Tam. We could measure their weight, or more specifically, we could measure their mass. For example, this guy could have a mass of 50 kilograms, and this guy could have a mass of 100 kilograms. So mass here is something we could measure. So we would say that mass is a physical quantity. Similarly, we could measure their heights. For example, let's say this guy is 170 centimeters tall, while this guy is 200 centimeters tall. We would say that we measured their height, or you could say this is length here. So length over here is also a physical quantity. Now we could divide these physical quantities into essentially two groups. One of them is called a scalar, the other we call vectors. And in the simplest of terms, scalars are quantities like mass and length. They only need a value and a unit for you to express them. For example, here we just said his mass is 50 kilograms. We don't need to specify anything else for you to we don't need any more information for specifying his mass here. Similarly, with length, we only needed to specify a number or a magnitude and a unit here. However, there are some quantities that require more than just those things. For example, a car moving at 10 meters per second to the right and a car moving at 10 meters per second to the left aren't the same thing, right? These two are different quantities. And how they differ is not by value or unit, rather by direction, because this one is moving to the right and this one is moving to the left. So there are certain quantities where you don't just need a magnitude, you also need a direction. We essentially call these types of quantities vectors. So in the simplest of terms, we could say that a scalar only needs a magnitude, while vectors need a magnitude as well as a direction. So examples of scalars and vectors would be, here mass and length are scalars, and force or velocity or acceleration, these quantities would be vectors because they have both mass, but they have both a magnitude and a direction. However, this isn't really enough to classify something as scalar or as a scalar or a vector. For example, let's say we have a circuit here. This is our battery here, and let's say there's a current of 1 ampere flowing from this direction like this. Here current is flowing from here to here, so just from this arrow you could probably tell that current has a direction, right? So it fills both criteria, like it has a magnitude as well as it has a direction. But current isn't actually considered a vector. It's not a vector, rather a scalar quantity. The reason for that is we actually need to add another condition here. That is, vectors need to obey the law of vector addition. Allow me to expand on this. For scalars, let's say we have a scale here, like a weight scale where you measure something's mass. If you put an object of 50 kilograms and then on top of it, if you add like 20 more kilograms, we're gonna see a weight of 70 kilograms, right? You just add these two together. Even if you swap these two objects around, like if you had the 20 kilogram on the bottom and this on the top, we would still get 70 kilograms regardless, right? So scalar quantities, with scalar quantities, all you need to do is add the values up if you want to get a result of like adding those values. However, let's say we have some object here and someone's pushing it to the right with a force of 10 newtons. And let's say there's another force here of 10 newtons at the same time. Someone's pushing it to the left with 10 newtons. Here, the result of these two forces is obviously going to be 0 newtons because the object isn't going to move. However, if both people were to push it at the same time from the same direction, it would have moved to the right at feeling a force of 20 newtons, right? So here you can see that, you can already see that the values isn't all that matters, because in both cases we have 10 newtons, but the result differs. For another example, let's say we have the object here and someone's pushing 10 newtons from here, someone's doing that from here. Intuitively, you should be able to tell that this object is going to go along this direction, let's say at an unknown newtons amount of force, feeling an unknown amount of force. So here we change the angle up again, 90 degrees, and the direction as well as the value of the force would change here. So notice how with force is a vector, so with force, when we're adding two forces up, the values aren't the only thing that matters. The angle between them also matters here. So this is essentially the vector law of addition, where we state that the sum essentially of two vectors matters both on their value and magnitude and direction. Here that didn't happen, so it was a scalar. However, here it does happen. So actually, in terms of current, even if we have something like this where, let's say there's 1 ampere current flowing through this wire and there's 2 amperes of current flowing through this wire, if they flow out from here, they're gonna always result in 3 amps regardless of the angle between them. Like here we have an angle of 90 degrees. Even if we had a different angle, for example, let's say we had something like this where 1 amp is flowing through here, 2 amps is flowing through here, and 3 amps would flow out through here, even though the angle is different here. So current essentially doesn't follow this third condition here. It doesn't obey the law of vector addition, so we don't consider it as a vector. It's instead considered as a scalar. A similar quantity would be pressure, where pressure also has magnitude and direction but doesn't follow this law here. So yeah, that's how you could differentiate between scalar quantities and vector quantities. And that's pretty much it for the video.